In this second video, we're going to look at what would happen if we had our function of velocity with respect to time and we wanted to go back and find displacement. Well, what we just need to remember is that integration is the opposite of differentiation. And obviously you may have had some experience of differentiation and integration if you're already well into Unit 1 or you did the Add Maths course. So if you recall from our previous video, velocity is given by dx by dt, i.e. the differential of x with respect to time. What we can then say then is, if we wanted to return back to displacement, it would be the integration of v with respect to time. Similarly, if we have acceleration, which is the differential of our function with respect to time, our velocity function with respect to time, we can therefore say, well, to reverse that, velocity will be the integral of acceleration with respect to time, and therefore reversing the process that we did in our previous video. Now, what we've got to remember here is these are what we call indefinite integrals. Now, indefinite integrals mean they have no limits. There are no numbers at the top and bottom of the integral symbol. That means we need to have a constant of integration. And this is really important because this is what makes our function work. So what we normally get are things called initial conditions. So our initial conditions usually take the form of, when t equals 0, what would x or v equal? And that will allow us to find our constant of integration. Or we sometimes get a phrase called initially. You may find initially the particle is 3 meters from the origin. Well, initially is basically a disguise word for the time equals 0 as well.